Welcome back. Today we are going to study load frequency control with integral control, which is an essential topic in power system operation. We will understand how frequency deviation occurs, how governor control responds, and how integral control eliminates the steady state error. So let's begin. So we know that power system must operate at nearly constant frequency at 50 Hz in India. When electrical load changes, suddenly the balance between generated power and consumed power is disturbed. If the load exceeds the generation, the frequency decreases, and if the generation power is more than the load, so applied on the generator, then the frequency increases. So this is how there is an imbalance, and this causes a frequency deviation. Frequency stability is critical for grid reliability. So before going into the study of frequency deviation, we will first look how frequency is dependent upon the speed of synchronous generator. So the frequency of synchronous generator is given by Pn by 120, where P denotes the number of poles, N denotes the rotor speed in RPM. So whenever there is a decrease in the speed, frequency decreases, and whenever there is an increase in the speed, frequency increases. So there is a direct relationship between speed and frequency. But how this speed decreases or increases? It depends upon the load so applied on the generators. So if load is more than the previous value, speed automatically decreases, and if the load is lesser or removed from the generators, then speed increases. This is how your change in the speed occurs. So there is a load disturbance in power system. Suppose a very large industrial load suddenly connects to the grid. The electrical power demanded from the generator increases immediately, but turbine mechanical power is still rotating at previous speed. The rotor cannot immediately change its speed, and there causes the drop in speed and thus the frequency. So this deviation of the speed and the frequency is detected by governor mechanism. So first loop in this control is governor mechanism loop, where the governor mechanism detects the frequency change and adjusts turbine input accordingly. So this response is very automatic and stabilizes the system. However, the governor alone cannot do so. Governor just detect the frequency deviation or change in the turbine speed, but there is always an error in the speed, that is from its actual value to the nominal value, and thus there is a difference in the frequency from its nominal value and actual value. So this difference is nothing but the steady state frequency error. Now here comes your second loop, which is nothing but a integral controller loop. So before going into that, first have a look that steady state frequency error is nothing but the difference in the nominal value or desired value with respect to the actual value. So whenever the load is applied, there is a change in the speed and change in the frequency. Now frequency comes to another equilibrium level, which is lesser or greater than the previous value. So whenever there is a certain difference between nominal value and the actual value, it is nothing but a steady state frequency error. So this error is controlled by the secondary control, which is nothing but an integral control. So integral control is defined with the help of equation Ki integrating error dt. Here Ki is integral constant. So So integral controller continuously integrate the steady state frequency error as long as error does not exist. The controller output increases or decreases generation until the error becomes zero. So this is the function of integral control. So the LFC, load frequency control, on and all, you got to know that any deviation in the frequency is detected and processed by the controller. One is governor mechanism, another one is an integral controller. So integral controller modifies the reference power setting of the generators. So here is a simplified diagram representing the load frequency control loop in a single area power system. A load disturbance causes a frequency deviation. The integral controller processes the error and sends the corrective signal to the governor, and governor adjusts the turbine input power, which changes the generator output and thus restoring the system frequency. I hope you understood the summarized version of this automatic load frequency control. So in real power system, load frequency control is implemented through automatic generation control system. This system continuously monitors frequency and adjusts generator output across different plant. These are operated, AGCs are operated by load dispatch center, maintain frequency and tie line power. These are mainly used in interconnected power systems. So let's see its applications. It is used in national power grid, interconnected multiple area system, mainly in hydro and thermal generating stations, and also used in modern smart grid control. So I hope you understood today's lecture. I'll come back to you with another important topic of power system operation and control. Thank you so much. If you have any doubts, please comment in the comment section below so that I can rectify it as soon as possible. Thank you so much.